Okay, this section, this idea is one of the harder ideas in calculus to wrap your head around. When I took it, awesome, great to know. When I took it, we had to do proofs on this, and they were called delta epsilon proofs. We don't have to do any proofs on this. We're going to actually do some algebraic stuff with it, and you'll have a process, and it will not be hard. But just reading these is kind of scary. Okay, so we're going to get past that. It gives you, we're talking about the precise definition of a limit. We kind of know a little bit about what a limit means, that as you get close to something on the x, where is the function approaching? We kind of know a general idea. This is a precise definition. Let f of x be defined on an open interval about x sub 0, so some point, except possibly right there at x sub 0. We say the limit of f of x as x approaches x sub 0 is the number L. Okay, so that's fine. That's just the way we write the limit. If for every number epsilon greater than 0, epsilon's just a Greek letter, we're just saying it's a number, there exists a corresponding number delta greater than 0, such that that this thing falls between 0 and delta, and that means the limit falls, that f of x minus the limit falls below epsilon. That sounds crazy, doesn't it? It doesn't mean anything to you. It doesn't make sense to you. We used to have to prove these. We don't have to do that anymore. So what I wanted you to see it. We're not going to spend a tremendous amount of time, but we are going to do this algebraic thing. So here's the rules. How to find algebraically a delta for a given function, limit, x sub 0, and an epsilon. So you're going to be given some things, and you've got to find this item. All right. Number one, you're going to solve an inequality, f of x minus the limit. Okay, so we're going to do that less than epsilon. And you don't have to write that down right now because I'm going to show you in the first problem. We're going to go through it completely. But every time we're going to solve this inequality to find this interval on which the inequality holds true. Okay, then we're going to find a delta that works. So we're going to do this whole process. You don't have to worry about those words. What you need to worry about for this, for me, is the process. So let's just go and look at the first problem. Okay, this is the way your homework problem will read. For the given function, find the largest open interval on which the inequality holds. Then determine the largest value for delta greater than 0 such that this holds true. Okay, so here's what you're given. F of x is 5x plus 6. The limit is 41. X sub 0 is 7. And epsilon, I think that's supposed to be an equals, 0.2. Okay? So on each of these, what we're going to solve is this. F of x minus the limit in absolute value signs is less than epsilon. Okay, so we're going to plug in the parts that we have. The absolute value of f of x, that's 5x plus 6, is less than, what's our epsilon? Oh wait, I have to minus the limit, sorry, minus 41 is less than 0.2. Okay, so it's always the f of x minus the limit, that's an absolute value, has to be less than the epsilon. Okay, do you agree that if this is absolute value, we can actually write this as negative 0.2 less than the positive 0.2? Do you understand that? Because it was absolute value, so you have negative on this side, positive on this side. Do you remember that? Okay, so every time we're going to start out with it in the absolute value, Then we're going to rewrite it where it's not an absolute value and we have negative over here and positive over here. And then we start cleaning it up and solving this inequality. What can I combine these two? Okay, so 5x minus 35 is less than 0.2 and negative 0.2. All right, then what do you do to solve that? What do you do to solve an inequality? Yeah, because to all sides, you know, to this, to this, to this. So just to show that, I'm going to do a plus 35, a plus 35, and a plus 35. Okay. What do we get on this end? You got your calculators. 34.8 is less than 5x is less than 35.2. All right, everybody with me? Okay, now what do I need to do to solve that? Divide everything by 5. And again, your calculator will be handy. If you need a calculator, there's one here, if you don't have one. Yeah, just grab one. Okay, so what do we get on this side? Oh, 4? Okay, so that's the interval that they're looking for. That's the interval that's going to make that all hold true. So this is what they're looking for the first answer. Because up here, how did it read? Use interval notation. So that's what you're going to put in that first box. That's the interval. And then it wants that delta value. Since x sub 0 equals 7, you were given that up here. X sub 0 equals 7. What are we away from 7 on each of these? 0.04. Then that means that delta is 0.04. And that's the second part to the question. Okay. Okay, well, they gave us a problem. Get away from the voice here. Since x sub 0 is 7, that's what we're trying to find. What is our interval on either side of 7 that we can still stay where we need to be? And so we can go 0.04 on either side and we'll still be there. Okay? That's how far we can go from 7 on the right or on the left. Does that make sense?
Now, would x sub 0 always be right in the middle of the two numbers complex?
The way we're doing it. Yeah. Okay, so let's work this next one. All right, so you're given, here's your f of x, here's your limit, here's your x sub 0. Can you guys see those or not? Make it a little bigger. Is that better for you guys on the back? Okay, so we're always solving f of x minus the limit is less than epsilon. And we've got it in absolute value. Okay? So I've written that there, and I actually went ahead and rewrote it over here in the red. That's just taking the absolute value off and putting the negative over here and the positive over here. Okay? We'll write it here. Okay. I keep wanting to forget that. Okay, what would you do to solve this? First thing. Okay, so if we add 11, okay, Now how do we do that? Square everything in the whole thing. So you're going to square 10.99. Does it give us, it says round to 4 decimal places, so in that question it mentions that. So when you square this, let's write it with 4 decimal places. So square 10.99. What do we get? 7801. Okay. And then we have 14x plus 51 here. And then when we square 11.01, okay. So we squared everything across the board, and now we've gotten rid of the radical. Now what do we need to do? Minus 51. Okay. Did you get 69.7 and 70? Okay. And then we will divide by 14. And what do we get? 4.23. Okay. And then over here? Okay. All right. So here's our interval. Right here. Okay. And what was x sub 0? X sub 0 was 5. Then delta is what? What are we within on each side? 0.0157. Okay? Okay. We okay? Okay. All right. How about you try this one? Okay, f of x is x squared, limits 25, x sub 0 is negative 5. Now we hadn't had an x sub 0 that was negative 5, so when you get down to your interval, at one point when you've defined the interval, go ahead and multiply everything by negative, and it'll change your interval, because you need to be within parts of negative 5. You'll see what I mean when you get there. So try that. Let's just see how well we do. Hold on one sec. Trying to find that. Okay, so there's the work for that one. Most of you seem to have gotten it. A couple of things came out in questions that I was hearing around the room. James had a good point about distance, that we're talking about distance and it can't be negative. You were talking about this, right? That your delta is not going to be negative. It's got to be positive, because you're saying you're given this stuff here. And how much can x vary and still be less than your given epsilon? And so that's where this interval comes in, and you're saying, oh, well, I can go to this side of negative 5, and I can go to this side of negative 5. And I'll still make that true. And then what is the distance that you can go either side? So the distance itself has to be positive. So this guy's always going to be positive. Okay? All right. So let's try one more. What are we on? 4? Okay. It's a little bit different. For the given function, and the point and a positive blah blah blah, find a number delta greater than 0. Okay, so we're given all the same stuff, but what are we not given? We don't have the limit. Okay, we still have to do this inequality, so somehow here we've got to find the limit we're talking about. And what I've written here is what might help you. Since this is a linear function, and if you were trying to find the limit, L is the value of f of x at x sub 0. for this question. Well, what's x sub 0? 2. So the L, the limit, is 7 minus 5. Substitute in 2 for x, and the limit would be negative 3. So that would be the first step of the problem. Find the limit, and then go ahead and solve it like we've been solving it. Okay?
So you just plug 2 into that x, solve that.
Right, because if I just asked you, Leland, to find the limit as x approaches 2 of 7 minus 5x, you would just plug in 2 into that, and you would get the limit. So that's where we got that.
Supposing it wasn't a linear equation, you have to do the way we're doing it yesterday. And then
Go from there. I'm not going to give you one of those. That'll be good. All right. So we'll go on and work that one. And you can be working it. I'm going to work it up here as well. And so we'll meet in the middle. Oh, do you have all the stuff written down? There we go. I'll give it. I would say you could count on having one of these on the test, just like this, the algebraic solving of this, but not like this. I mean, like the others that we've been doing. Yep.
So when you go to do this problem then, what do you set it up as 7x minus negative 3?
So you're going to have absolute value of 7 minus 5x minus a negative 3 less than 0.01, because that was what you were given. Right here, that one? Okay, what is 7 minus a negative 3? In that 7 plus 3? I didn't write that all out. I just went from there to there. Sorry. Okay. So what we noticed that we didn't do, that I didn't write correctly, was that when you divide by this negative 5, the inequality sign flips. So when you do that, then it flips here, and that makes sense. X is bigger than 1.998, but less than 2.002. Didn't change the final thing here, but this is the interval. And actually, you might write it like 1.998, comma, 2.002. That would be the better way to write that. Yeah. So let's go back and look at. Oh, it's multiply or divide. Yeah. Yeah. Let me see. Let me go back because I had the work. I didn't work that one there. Let's see. Where are we? Is it number 3? Okay. Let's look. Yeah, it definitely, well, it reads right, that one.
No, it doesn't. Negative 5 is less than negative 5.
Well, you want your negative, you want your smaller one on the, you're going left to right.
Negative 4 is greater than negative 5 is smaller.
I just wrote it right here, didn't I? But I didn't have it here right. Didn't, this is
Yeah,
right.
yeah,
Because that's what I was looking at, saying, that's right, that's right. So, but here it is not. It needed to be this. That's, it did change. It did change. I'm so glad you caught that. Because I wrote the interval right, but it wasn't what I had written there. Okay, so we're good? Now you'll know that on those you want the lower value on the left of the interval. Definitely. Okay, so we're good? Well, in order for this to be a true statement, it wasn't right the way I have it written. Because when we multiply by the -1, it will flip this from here to here. Okay? And so then when you put it in this format, you have to make sure you're right. So x is greater than this guy, but less than this guy. Okay. All right, was that, do we have one more, or is that it? That was it. Oh, that was it. Wow. Okay.